Hello everyone, I'm Viraj and today we guys are going to see something about an operator in a Python. So first thing first, what is an operator? Operator. Operator are used for perform some operation on value or variable, you can say that. So we are going to perform some kind of operation on a value. So what kind of operations we are going to perform? Arithmetic operation, logical operation, comparison operation, and so on. So let's see all these types of operators. Arithmetic operators, assignment operators, comparison operators, logical operators, identity operators, membership operators, and bitwise operator. These are a common operator that we are going to use it. So let me first see about an arithmetic operator. Okay. In arithmetic operator, what we have? We have addition, subtraction, multiplication, division, modulus, then floor division and exponentiation. So we can have a plus, minus, division, multiplication, modulus, exponent, and floor division. Let's see the practical implementation of it. For example, 10 plus 10. If we run this, we will get a 20 as output. 10 minus 2, then it will be the 8. 10 multiplied by 5, which is going to be 50. Then 10 divided by 2, we are going to get a 5.0. Then, for example, 10 multiplied by, or we can say that exponentiation 2. What we are going to get? 100. 10 and 3, we can get 1,000 and so on. For example, if I do the modulus 2, what we are going to get is 0. 10 double slash 2, which is going to be floor division, which is going to give you the 5. What is this 0 and what is this 5? Let's see the one of the example. So for example, if I'm doing a 2 and 10, 2 divided by 10, what we are going to get it? So guys, we are going to get 2 5s are 10. The remainder is going to be 0. So whenever you use a modulus sign, then this value is going to get picked up, and whenever you use double slash, which is a floor division, then you will get this 5. So this is what exactly happens internally. So this is how we can use an arithmetic operator. Then next we can see comparison operators. In a comparison operators, what we can do? Equal to, then not equal to, greater than, less than, greater than equal to, less than equal to, and so on. Let me make a markdown. Let's see the practical implementation. All these comparison operators are going to return the Boolean result. So 10 is equivalent to 10, which is correct. So what it is going to return? It is going to return a true. If I'm saying 10 is equivalent to 5, which is not, then it will return a false. Similarly, 10 is not equivalent to 10. Ideally, they are equal. So that's why it is returning a false. For example, 10 is not equivalent to 5, which is correct. Then it will return a true. 10 is greater than 5, correct. 10 is greater than 10, again false. 10 is greater than equal to 10, which is correct, because both the values are equal to or greater than, means they are satisfying one condition, which is a equal. 10 is less than 5, which is not possible. 10 is less than equal to 5, which is again not possible, and return a false. This is how we can do the comparison. After this, what we can have a logical operators. In a logical operators, what we have, guys, and, or, and not, and, or, and not. Okay. Let's see the practical implementation of it. And required, all condition must be true. Then only a result will be true. One of the condition is true, then result will be true. If all conditions are false, then a result will be false. Okay, and in a not, reverse the result. If a result is true, then return false. If a result is false, then return true. It will reverse it. Let's see the practically. 10 is equivalent to 10 and 5 is equivalent to 5. Both conditions are true on a left hand side, on a right hand side. Both conditions are true. Then result will be true. 10 is equivalent to 10 and 5 is equivalent to 10. Now one of the condition is false. So this on the left hand side, this guy is a true, and on the right hand side it is a false. And internally what happens? True and false, result will be false. So if you run this, then result will be false. To understand this, what we can remember this kind of table. True and true, only result will be true. True and false, result will be false. False and true, result will be false. And false and false, result will be false. This is what we can understand. Apart from this, in OR as well, let me write for a OR as well. True or true, result will be true. True or false, result will be true. False or true, result will be true. False or false, result will be false. This is what we have to remember. In a not, if I am writing a not true, result will be false. Not false, result will be true. This is the formula that we have to remember, guys. Let me take an example for OR. 10 is, or even we can write it directly, Boolean fields as well. True and false. True and false. False. But true or false, you can see this. True. In input number 20 and 21 and output of a 20 and 21, you can compare it. Only logical operator is got changed, which is a and an or. If both the conditions are false, false or false, then result will be false. But if the one of the condition is true, then OR will return a true. Not a true, you can see this, false. Not false, then it will return a true, something like this. Then we can use a identity operators, identity operators. In identity operators, what we have a is and is not. Is and is not. Return the true, both the values are the same, and if it is like if the both the values are same, return true. Return true if both values are not same. We can run this and let's see. 10 is 10. So even you can see that there is a syntactically warning it is giving. It is saying that do you mean equivalent? Do you mean equivalent? If I am doing something is not 10. Guys, this is a warning. This is a warning. This is not something like a error. This is a warning. So it is saying that do you mean something like this, not equal to whatever we have seen in logical operator. So you can see that, guys, it is not equivalent to means the value should not be equal, and is means equivalent. Okay. Next operator is a membership operator. In a membership operator, what we do? We simply check in and not in. In means what? Element is present or not. Present, then return true. If element is not present, then return true. Let's see the one example for this. For example, I am having a list which is having a 1, 2, 3, 4, 5, and what I can do, I can check if there is a 2 is present in this particular list or not. I don't have to iterate it. I can use a simply in operator and I can run this. 2 is available, then it will return a true. If I'm saying a 22 in particular list, no, it is not available, then it will return a false. Similarly, if I'm doing a 2 not in 1, 2, 3, 4 and 5, run this. You can see the input number 27, which is a 2 in, and in input number 29, 2 not in. Output of them are different. Here it is a true because the value was present, and here it is a false. The reason that it is saying that if the value is present, then I am going to return a false. If I am writing a 22 not in 1, 2, 3, 4, 5, now it will return a true. Here in input number 28, you can see that same code we have written it, but we have not added a not, and the reason is like return is false. Here it will return a true. Let's see. So guys, there are a multiple scenario. Then we have to use this condition. And in last, which is going to be bitwise operators. In a bitwise operators, what we have a something like a am, and, or ampersand. Then pipe, which is going to be or. Then XOR. Then this is called as this cap is called as a XOR. Then this tilde sign is called as not. Then 0 fill left shift. And lastly, we have this is going to be sign right shift. So guys, this is all about for this operator video. What we have covered all the operators: arithmetic, assignment, comparison, logical, identity, membership, and Bitwise. So let's meet you guys in a next video. Thanks.